Okay, under common IoT security measures, so this will be the continuation of our security IoT. We have hardware security, as I mentioned earlier. Strong encryption is critical to securing communication between devices, and we may proceed to network security. Protecting an IoT network includes ensuring port security, disabling port forwarding, and never opening ports when not needed. Using anti-malware, firewalls, and intrusion detection system or intrusion prevention system. Okay? Blocking unauthorized IP addresses and ensuring systems are patched and up to date. Network access. So, network access control or NAC or NAC, no? It can help identify and inventory IoT devices connecting to a network, and this will provide a baseline for tracking and monitoring devices. IoT devices that need to connect directly to the internet should be segmented into their own networks and have access to enterprise network restricted. Network segments should be monitoring for anomalous activity where action can be taken should an issue to be detected. Security gateways. Acting as an intermediary between IoT devices and the network, security gateways have more processing power, memory, and capabilities than the IoT devices themselves, which provides them the ability to implement features such as firewalls to ensure hackers cannot access the IoT devices they connect. Patch management, continuous software updates. Providing means of updating devices and software either over network connections or through automation is critical. Having a coordinated disclosure or vulnerabilities is also important to updating, no, devices as soon as possible. Consider end-of-life strategies as well. IoT and operational system security are new to many existing security themes. It is critical to keep security staff up to date with new or unknown systems. Learn new architectures in programming languages and be ready for new security challenges. C-level and cybersecurity teams should receive regular training to keep up with modern threats and security measures. Integrating teams. Along with training, integrating disparate and regularly siloed teams can be useful. So for example, having a programming developers work with security specialists can help ensure the proper controls are added to devices during the development phase. Consumer education. So consumer must be made aware of the dangers of IoT systems and provide steps they can take to stay secure, such as updating default credentials and applying software updates. Consumer can also play a role in requiring device manufacturers to create secure devices and refusing to use those that don't meet, no, high security standards. With any IoT deployment, it is critical to weigh the cost of security against the risk prior to implementation. The IoT vulnerabilities, of course, continue to surface, causing confidence in the ability of manufacturers to deliver products that are secure by design to continue to erode. Already this year, several vulnerabilities have been exposed, including security flaws in smart cameras. Researchers discover vulnerabilities with Hanwha Techwin surveillance cameras. The flaws existed not only in Hanwha Techwin cameras but all smart cameras manufactured by Hanwha Techwin. Vulnerable medical devices. Medical imaging devices such as MRI or CT systems are becoming increasingly vulnerable to cyber attacks, according to researchers from Ben Gurion University. Hackable smart home hubs. Security flaws were discovered in a smart hub used to manage all the connected modules and sensors installed in the home, putting smart home owners at risk. IoT vulnerabilities are being discovered and exposed across all industries, and hackers are certainly not discriminatory when it comes to who they will target. Throughout countless examples, security flaws are regularly being found in IoT devices, putting sensitive data and even personal safety at risk. The the fundamental issue actually is that IoT devices are not being built with security in mind. As adoption of these technologies continues to rise, this has created a growing attack surface that does not take a particular high level of expertise to exploit. Everyone is eager to jump on the IoT innovation train, but in doing so, the critical element of securing these devices is often neglected. However, despite the risks, organizations are continuing to gather sensitive data from IoT devices. The 2018 Global Data Threat Report found that nearly three-fourths or 71% of organizations are aggregating data from the millions of IoT devices already in use. While IoT security was a whole remain lacking, we are nonetheless seeing more organizations starting to apply measures to protect IoT data. The 2018 Ponemon Global Encryption Trends Report found that 49% of enterprises are either partially or extensively deploying encryption of IoT data on IoT devices. Organizations are taking a step in the right direction of recognizing that encryption of IoT device data, done correctly, can effectively protect privacy and confidentiality. But challenges remain. At the end of the day, it comes down to trust, and trust is not established regarding the identity and overall integrity of the device. Then, encrypting untrusted data is not accomplishing the desired goals. And if the device and the data it collects cannot be trusted, there's no point in going to all the trouble of collecting it, analyzing it, and worst of all, making business decision based on it. How to build trust in IoT? Here is what required to enable trust. A root of trust to enable device authentication. To securely participate in the Internet of Things, every connected device needs a unique identification. There are various methods used today to prove an identity, from password to biometrics to digital certificates and more. However, when it comes to proving the identity of an IoT device, the choices available for authentication depend on the capabilities of the device. In environment where security and safety are paramount, a hardware-based root of trust provides the strongest means of establish and maintain an authenticated device identity. Digital certificates issued from a trusted public key infrastructure provide a proven mechanism for this. However, this is the storage and processing demands of traditional RSA keys have driven some to favor elliptic curve cryptography, or the ECC provides equivalent protection to RSA, which much smaller key size and its operations required significantly. The other answer will most likely be by a partnership between IoT vendors and IT security vendors, taking the already advanced security techniques or technologies and hardening them to work in the organizational, cultural, and technical OT environments. IoT is a more difficult issue in that these unpatchables must be segmented and surrounded by intrusion prevention system and anti-malware. Instead of a pre-patch shield, this becomes a never-can-patch shield. Segmentation and shielding, especially via wireless connectivity, become the future stage. The bottom line is that not all IoT is created equally and can't be secured equally. But IoT is here and the bodies know it to be a soft underbelly. The two solitudes of the organization representing IT and OT can together secure OT, but it is up to mostly IT to embrace and secure consumer-grade IoT technologies. Don't fall into the traps set by these myths. Be informed and get to work, not on fixing all things. All IoT Agenda Network contributors are responsible for the content and accuracy of their post. Opinions are of the writers and necessarily convey the thoughts of IoT Agenda. We will also consider the less processing, making it appropriate for devices with less storage space according to processing, of course, power and battery life. Unfortunately, many IoT devices aren't being designed with even the most basic of security protection, such as requiring default administrative credentials to be changed upon installation. A reasonable level of trust cannot be established in a device until there is a solid means of device authentication in place, and that the integrity of the device can be assured over time through mechanisms such as secure boot protection and code signing. These are important to prevent introduction of malware, especially during firmware updates. Number two, encryption to protect data. With a proper root of trust in place, it is increasingly important to have means in place to protect IoT data which is sensitive, personally identifiable, or proprietary. In IoT, this means protection on the device itself when the data is being transmitted to intermediate points such as IoT gateways, and when it en route to final destinations such as the cloud or the data center for storage and analysis. This requires not only process step to identify the specific data to be encrypted, but also a key management scheme to distribute and manage the keys that are used to encrypt the data. Secure storage and access control for keys requires planning, and they must be able to permission people entities to enable data access but properly segregated from the data and stored securely. It might sound easy, but IoT scale and speed is a game changer. Keys have a finite lifetime based on their length and the algorithm being used, and therefore must be rotated at regular intervals. Lose a key that is used to encrypt data and you lose the data key management is a crucial capability for IoT deployments with sensitive data. The adoption of IoT technology is not expected to slow down anytime soon. In past, Gartner predicts the number of connected devices will rise to 20.4 billion by 2020. Trust is recognized as a key enabler for IoT to deliver the intended results, and authentication and encryption are two critical capabilities in the IoT Trust Playbook. All IoT, of course. Why enterprise IoT security is critical? It was just over a year ago when the Mirai botnet made its dramatic debut on the world stage. After initially flooding a security journalist website with traffic, it went on the grind the internet to a halt for millions of users. This botnet did this by overwhelming Dyn, a company that controls much of the internet's domain name system infrastructure. Since then, variation of the malicious source code had been used in a number high-profile attacks on internet infrastructure. Mirai and its offspring are self-propagating botnets that target and infect poorly protected IoT devices by exploiting people that repeatedly use default username and passwords. No? One hijack, these devices had been used to mount some of biggest distributed denial of service attacks, no, we've ever seen. Changing landscape. In some ways, enterprise IoT security is being managed a bit like IT security was way back in 90s. As an afterthought, this has to stop. After all, we forecast that there will be 20 billion connected IoT devices by 2023. Clearly, there are new and different security requirements than there were in the past. IoT devices are being targeted for many reasons. Open for understanding of enterprise IoT security leads to weak protection for many IoT devices, which makes them easy targets for hackers. IoT devices are being targeted for many reasons. Again, okay? Many IoT devices still don't have advanced security features, and this is especially true of simple devices such as temperature sensors, which have limited processing power and basic operating system. As they are designed to be plugged in and forgotten about, owners tend not to security updates frequently, if ever, making it quite easy for an attack on such devices to go unnoticed. In a connected world, no, these simple devices can be connected to more critical system farther up in the network. If if ever a small, simple device malfunctions or is tampered with, it can lead to serious security issues. The Mirai botnet actually was an eye-opener, not least because it neatly illustrates that the IoT industry is facing ominous threats and that we need to prioritize securing the IoT ecosystem, but what can be done to help secure the IoT? Okay. So the prevalence of insecure IoT devices make it likely that for that foreseeable future, they may be one of the main entry points for future attacks on mission-critical system. The silver lining is that IoT botnets can be averted if IoT vendors follow basic security best practices. In fact, all participants in the IoT ecosystem need to have security as a top priority, from device manufacturers through networks to platforms and applications, which means security is no longer a nice to have add-on feature. It is necessity. Enterprise IoT security is steadily becoming an issue of high concern. Measures are being taken by many IoT vendors to prevent security breaches at the device level, and efforts are being made to tackle major disasters before hack occur.